you might think of that as three things that are interconnected. So one of those is your knowledge base. So what do you know about what it is you're designing? Then you need an idea that you're going to try and develop, and then you need some way of evaluating that idea, testing it, and it's all those three things are connected. So I think the role of Cambridge is to fill up your knowledge base, give you more information on all kinds of engineering. So mechanical engineering, structural engineering, fluid dynamics, thermodynamics, information engineering, software, manufacturing, electrical engineering. That's all going into your knowledge base.
Yeah. Okay.
So that when you have an idea, then you imagine you're a bridge designer, say.
Yeah.
You don't just sort of paint the bridge and kind of hand it over.
Yeah.
So it's the engineer's job to make sure the bridge is going to work.
Yeah.
So you use your knowledge base, like what are the loads in the bridge? Can the material stand those loads? How much is it going to deflect? Are the people on the bridge going to be happy with that? And you can calculate those effects. So in Cambridge, we're going to show you how to do those calculations, and they might just be pen and paper calculations, or they might end up being big simulations. And then you're going to do some kind of maybe physical test with a model, and then you see the results of those tests. Those results go back into the knowledge base, and so it's all a feedback engineer. So it's the technical stuff, but also the process, I think, that I would describe engineering as.
Hello everyone, welcome to Cambridge from the Inside, and we're here with a new guest today. Would you like to introduce yourself?
I'm Professor Graham Pullan. I'm a fellow in engineering here at Trinity Hall, and I work on aerodynamics in the engineering department.
Nice. And today we're going to be talking about studying engineering at Cambridge and engineering admissions advice as well. So if you're thinking of applying for engineering and studying here, stay tuned as we're going to go through everything about the course and the admissions process. So for anyone like myself, viewers watching and don't really know what engineering is, can you explain what engineering is for us?
Yeah, I'll take a shot. I'd say that engineering is the development of technology to solve problems. So go into that in a bit of depth. So technology in the broadest sense. So we got microphones, video cameras here. I traveled down on my bike, I crossed a bridge. Almost everything that you're interacting with day to day that has been made, has involved an engineer, and a bunch of stuff that hasn't been physically made as well, like computer software, control algorithms, methods. They're all involving engineering. Engineering is also about the process of designing those bits of technology. So you might think of that as three things that are interconnected. So one of those is your knowledge base. So what do you know about what it is you're designing? Then you need an idea that you're going to try and develop, and then you need some way of evaluating that idea, testing it, and it's all those three things are connected. So I think the role of Cambridge is to fill up your knowledge base, give you more information on all kinds of engineering. So mechanical engineering, structural engineering, fluid dynamics, thermodynamics, information engineering, software, manufacturing, electrical engineering. That's all going into your knowledge base.
Okay.
So that when you have an idea, then you imagine you're a bridge designer, say. You don't just sort of paint the bridge and kind of hand it over. So it's the engineer's job to make sure the bridge is going to work. So you use your knowledge base, like what are the loads in the bridge? Can the material stand those loads? How much is it going to deflect? Are the people on the bridge going to be happy with that? And you can calculate those effects. So in Cambridge, we're going to show you how to do those calculations, and they might just be pen and paper calculations, or they might end up being big simulations. And then you're going to do some kind of maybe physical test with a model, and then you see the results of those tests. Those results go back into the knowledge base, and so it's all a feedback engineer. So it's the technical stuff, but also the process, I think, that I would describe engineering as.
Nice, that's really interesting. And one thing that strikes me is that it sounds, and this has always struck me with engineering, it sounds very different to any of the A levels that students do. And just wondering if you're like, even when so for students who are studying the A levels, how would a student know that engineering is a course for them? Like, what kind of curiosities make you well suited to do an engineering course?
That's good. Yeah. So the in going back to the knowledge base, in that knowledge base, the rules of the game, so the rules that the physical world obeys, they're described really well by maths. So having an interest in maths is one thing. There's a lot of physics involved. You think about forces, energy, all different types of physics. So those are the core kind of technical things that you need to be excited about. But you also need some kind of, you expressed it as a curiosity, which I think is a good way of putting it. You have to be interested in how can I solve problems and come up with solving problems with new ideas, new devices, or developing improving existing devices. If that's what drives you, like there isn't a course on problem solving at A level. But if you know that's what excites you, then and you have the maths and physics background, then should be a good fit for you.
Nice. So it sounds like, and am I right in thinking when you were talking about that feedback loop of knowledge to practice and then knowledge again, is engineering a course where you're consistently going from theory to practice, and then that feeds back into the theory? And is that the
so well, it's really important that the underpinning science end of engineering is really solidly grounded. So the way that we deliver the course is a balance between theory and practice. So for example, in the first year of the engineering course here, there's 4 big themes. So you're going to get taught in mechanical engineering, which is going to include mechanics and also fluid mechanics and thermodynamics, which you won't have covered much so far. And then structures and materials, and then electrical and information engineering, and then maths for engineering. So that's a key thing in its own right. So you're going to go to lectures to learn those things. And you're also going to do labs, what we call labs. So they're sort of controlled practicals. So you have a couple of hours to work through on some piece of apparatus, which is going to help embed the knowledge that you've come across in lectures in some practical situation. Some piece of apparatus taking measurements. It's an experiment. But then there's more open pieces of coursework, which are more design orientated. So as soon as you arrive, you're doing a Lego Mindstorms project. So that's interaction of mechanical systems with software to solve a problem. So it's right into that loop. That's the first thing you do. And then there's a structural design project. You've got to make something to, I don't know, carry a load at a certain, supported in a certain way, and then you test that, and then you test it beyond the specification until it breaks. It's good fun. There's an integrated electrical project. You're making a design, make, and test of a radio. So again, that's sort of trying to show that loop to you. And there's programming in Python in the first year. That's coursework. Drawing, learning how to do engineering drawings with computer software to do those drawings. So there's always this balance of what you think of as the theoretical side, which we deliver in lectures, and then the practical aspects.
Nice. And for anyone who doesn't know, can you briefly just describe the differences between mechanical engineering, structural engineering, and information engineering? And is that possible to talk about briefly?
Yeah, of course. So it's just ways of dividing up the field. And this is sort of one of the interesting things about the Cambridge course. In fact, so I'd say all types of engineering you would study at Cambridge by going into the engineering degree. So we have one engineering degree. There's also at Cambridge, the exception is chemical engineering. So there's another degree, chemical engineering. But all the other types are in one degree. So, and I think it's a real positive. So it's a 4-year course. So the first 2 years, almost all of those 2 years, everyone is doing the same thing. So you're doing that mix. There's about 300 students, 320 students. They're doing that mix of subjects, which I will come back to and answer your question. And then right at the end of the second year, you start to specialize. And then third and fourth year, you're selecting modules that you're interested in. And so you're getting more specialized. So why is that a strength? Well, before we started, we were talking about these cameras. And so what's going on in the camera? There's motors to control the focus. There's electronics to control the motors. There's software. You were wondering whether the cameras were overheating. That's a thermal problem. So you've got all of those in your head as a Cambridge engineer, and you've got the fundamentals of those things. So we don't teach camera design. But you have the fundamentals of, okay, what's going on in this camera? Okay, I understand how we make sure that the heat gets out. How can we cool it? So you'd understand the fundamentals. So all these things, it's a long-winded answer, but all the things are connected and in a useful way for your whatever you do in the future. But to get back to it, so let's take one thing I mentioned, structural design. So you think of bridges, you think of construction, but you can also think of an aircraft wing. So that's the same the same governing maths, if you like. So there's a force on the wing, there's a structure down the middle of the wing's going to deflect. So that's again a structural engineering problem, and we link that with materials. So what are the different properties of materials? Which materials should I be using? Why do the materials behave that way? That's one thing. Mechanical engineering. So you students might come across some mechanics in maths at A level, and we add solid mechanics, the behavior of rigid things, fluid mechanics, how things flow, or why they flow, air, liquids, and then thermodynamics is heat and how we manage heat, and also how we can use energy to do useful work. The third one was electrical engineering. So that can be, power electronics, hundreds of megawatts, electrical systems, motors, and then small electronics, transistors and smaller down to integrated circuits, the whole thing. And we lump software in with that as well.
No, and then what's information?
Yeah, sorry, that's so we call it electrical information.
Okay.
So the software is the information.
I see. Okay.
But also control algorithms. Okay. Those are, and then the fourth paper in the first year is maths. So the maths is going to get used in everywhere in the course. So the students come in with a certain level of maths, and we build that up over the first 2 years, and then in some specialisms as well. And also we know that students come in with different experience in maths. So we make sure in the first year that people can reach the same level. But that you can see maybe so. The way I laid that out, so that's already like 25% of the four things. So it's a big component. So you've got to be quite excited about maths.
Yeah, nice. That sounds really cool. So, am I right in thinking, if I understood correctly, that I think a lot of universities have and they provide engineering courses, and it's a specific strand of engineering. But is one of the benefits of the Cambridge engineering course is that you would approach problems not isolating things, but realizing that they're interconnected.
Completely, yeah. I actually did my undergrad here, and I wanted to do aeronautical engineering.
Okay.
So you look up aeronautical engineering, you can't do it. So it's not happening at Cambridge.
Okay.
But keep looking because it's here, and it's an engineering. Like if you think of on aircraft, so you've got the fluid flow that you need to know, the structures. So you need to know these different aspects. I ended up working on the simulation of airflow, so that's software. I think it's a big plus. You might not want to keep trying to do everything for 4 years. So it's good that you specialize into what you really want to go for.
So at face value, it seems like someone can't do aeronautical engineering at Cambridge, but are you saying that it is the case that you can within the course?
Yeah, so you sign up for engineering. But then you'll see on the website that there are different engineering areas that you can specialize in, and aeronautical engineering would be one of them.
Oh, nice.
There'd be, electrical, or there's electronic information, mechanical engineering, energy in the environment, bioengineering, and also manufacturing. So you can see the different specialisms you can leave with.
And would I be right in saying that students who start the course end up specializing in something that they might not have realized at the beginning of the course?
Yeah, that's an interesting question, because the straight answer is yes, but you shouldn't. Some students, for whatever reason, correctly identify almost at the application process what it is they're interested in, and they continue, and then maybe in the third and fourth year you say, you're able to specialize in what you said. That's fine. Of course, you might think you're really interested in something, but then as you go a bit deeper, you prefer something else. That's also fine. And of course, it's also fine if you're not really sure, but you've got a passion for this problem solving and coming up with technology, and so again, you can steer your way through, and you don't have to make those choices. The first time you really make those choices is in the third term of the second year. where you pick like 2 options right at the end of the second year. So you don't even really have to think about it until that stage.
Nice. Yeah, it's a common theme amongst a lot of the courses in Cambridge, enabling students to have freedom and choose and carve out what they really want to do before committing. So, with regards to more the admission side and entry requirements, what are the entry requirements? I know they differ between the colleges, but what are the entry requirements for engineering, and do you need specific subjects to apply?
Yeah, you do. So it's going to be A star, typical science offer.
Yeah.
And the subjects that are important are maths and physics. So we're going to, here, we normally look for the A stars to be in maths and physics. That might vary across colleges. And the normal extra question is further maths. So if you have access to do further maths, and let's say at the school that you're at, then do it. Why should you do it? So it's just, well, a couple of reasons. So doing further maths, you're doing more maths. Remember, we were sort of saying how important that was.
Yeah.
So you're doing more maths, so it makes the standard A-level maths, you become more fluent with that by default. And doing the further maths, you start to get more of the maths that we're going to rely on here in the engineering degree. So yeah, it's we expect students who are in a position to do further maths to be doing it. Yeah.
Nice. And say say if a student is in a school that doesn't provide further maths, would it be advisable for them to try to do some further maths, even if it's like an AS or not towards a specific qualification, just in their spare time?
Yeah, if that was possible and that could work out, that would be great. Yeah. So there are these situations where you don't have access to A-level further maths, but the more maths you can do and the more maths you can demonstrate you've done at that advanced level, the better.
Nice. And applicants can mention that in their personal statement or My Cambridge application if they're doing any extra studying. So the other part of the admissions side of engineering is there's an admissions test. Could you explain to us?
So I'd say the little step back. So there's another set of three things. This one's about the applications process. So you've got the applications form. All your information on that's going to include your personal statement, questions, how you're doing and what A levels you're doing, how the teachers think you're doing in those A levels, and then you might think of eventually your grades as being part of that package. And then the second thing is the admissions test, which we call the ESAT, which we'll talk about. And then the third is the interview. And we're looking at all of those things together. So the ESAT, all applicants have to sit the ESAT. And for engineering, it's multi-choice. And for engineering, you do maths, maths 2, and physics. And I just advise, just take that seriously in the way that you'd be taking your school's studies seriously. So preparation, there's specimen and practice resources on the ESAT website. One thing worth mentioning is the ESAT for us is quite new. So before that, we still had an admissions test, and that was called we call it the ENGA, ENGAA, ENGA. So you might come across those resources online for previous ENGA papers. So they're worth looking at as well. The more practice you can get, the better. So prepare as well as you can for that.
Nice. Yeah, we'll put a link to the ESAT website in the caption, and it has the specimen paper and the past papers to the ENGA, so that you can practice for that and prepare as much as possible. And can you tell us a little bit more about the engineering interviews and what they're like?
So at this college, there'll be two interviews, and they're about 20-25 minutes long. There'd be you, the candidate, and two interviewers. So it's 3 people, and it's either going to be online or it's going to be in person. But the content is similar. So what is the content? So we're present the candidate with a situation that they're likely to be relatively unfamiliar with. It's not. There are no tricks. So here's the situation. How would you tackle this situation? And using your knowledge from the schoolwork. So it's going to be maths and physics. So I don't know. It could be a electrical circuit that we sketch out, or it could be forces, for some sort of force balance. It could be something a bit more abstract, but you're still able to tackle it. So if it was in person, we'd likely have paper and pen, and if it's online, we use the online whiteboard. So we pop up a situation, and then it can feel a little bit like we're all working on it together. Obviously, we're trying to get the candidate to do the work. But one piece of advice is just explain your thinking, your process when you like, okay, this looks like a force problem. I'm going to maybe need to resolve some forces, so I'm going to set up the angles here and so on. And then you might get feedback from the interviewers. So listen and react. So what do I mean? So one situation is we know we have to really stick to the schedule, as you can imagine. So maybe 10 interviews a day, and everyone's got a start time finish. We can't muck with that. So the candidate might say, "All right, I think you can solve the problem this way," and maybe start on that route. And they might well be right, but it might be going to take a bit longer. So you might down another route. So you might hear the interviewer say, "Oh, that's a good approach. That would work. Are there any other angles you could take?" And so
I guess if you don't talk out loud your thinking, the interviewer has no idea what's going on. Then will struggle won't be able to guide you.
Yeah, that's right. And don't overdo it. So you can get some equation, some situation where I say, right, I'm gonna use F equals ma here. So I'm writing F is equal to m times a. Like, okay, we don't need that. We know we're really happy that you're using F equals ma. Let's keep going. So don't. What am I saying? Don't slow yourself down by some kind of big narration that you're doing. That's not needed.
Just choosing what things need to be said and explained, and what and what things you feel like you need to voice out in case you might be on the wrong track, or just to communicate so that the interviewers know what's going on. I was just curious, like from the interviews that you've done in the past, what tips would you have, or pitfalls that you'd want future applicants to avoid that you've seen students go through in the past?
Yeah. One comment I usually make is when you're writing your filling in your application form, you might say you'll say a number of things that you've done, and as well as those kind of questions I was just saying, where you sort of set up a problem and you work on it, the interviewer might say, "Oh, I see you've." Usually at the start, I see you've had some experience of A, or you've done a little bit of work on B. So just think about what you've written or what you're writing, and just say, if I, and there's supposed to be like a softball question. So if somebody picked up on this, what would I say? And so occasionally, somebody might have kind of overemphasized something as being a kind of bigger thing than it was, and then you dig a bit, and just really unluckily in a way, the interviewer says, "What about this?" and there isn't so much behind it. Now that's not it's not a serious problem, because it's only supposed to be a softball question to get you into the meeting, into the interview, and then we get onto the technical stuff. But I'm sure that if you'd got into that situation, you'd think, "Oh, I shouldn't have done that." But so don't just think, "Oh, I can talk about this, I can talk about that."
Yeah, I guess it's a real shame if someone feels a bit caught out by that, and then that affects the rest of the interview.
Yeah. So, but that's a good general point. And it's tough, but because you can feel that you haven't done well on any part of it. But that's sort of okay. Everyone's not doing well on some part of it. So just and also you might have done better than you think, because one aspect of interviews is that the interviewers keep going. So you're sort of ticking all these boxes, and then just one further box, and that's a bit tricky. Well, don't worry. So it's really hard to know as a candidate. So just keep positive and go, okay, what's the next thing?
So would I be right in thinking that everyone would be finding the interview difficult because the interviewer's continuing to challenge you, so you don't get stressed out if you feel like that?
That's if you can keep that approach, that's right, and that might well be the situation.
Because I guess there's only 25 minutes, and you want to make the most of that time.
So trying to get through as much stuff, because you want to give the candidate as much opportunity to demonstrate what they're how they can apply what they've learned. So
if there's two interviews, are they both interviews on engineering, or is one of them more maths focused, or is physics involved?
Well, we've defined maths earlier as a subject, subset of engineering, didn't we? No, just careful. But so they're both technical interviews here. So we might pick up a bit on something on their personal statement, but both will be different aspects of engineering. So at least some of that will be on maths. And so some of it might, the answers to the answers to most of the questions might involve maths, but some of the questions might be a straight pure maths. That's also fair game. And then some of it, most of it will be the application of maths and physics, solve problems.
This might be a dumb question from me, but what's the difference between being asked a physics question and being asked an engineering question?
I think that in many cases, I haven't sat in a physics interview. But because candidates are at that point trained, have taken the same subjects. So that there's likely to be quite a big overlap between those questions.
would I be right in thinking as a upcoming engineer, you'd have to be it's more important for you compared to the physicist to be able to apply theoretical stuff and have like imagine what it is in the real world, whereas maybe that's not as important.
That's something that engineers have to do, but there's a lot of physicists would say they're doing that as well. So so you so at the university you can do engineering, you can do natural science, physics, or you can do maths, and all of those things overlap. So it's a question of emphasis. So you can if you're not sure just which subject to apply, just dig into all the possible options and see what's being taught, see what the experience will be like, and then really see what motivates you and excites you, because the degree is going to be hard work. It's going to be tough at times. So you want to be excited to get up and take it on, and that might be physics or maths. It might not be engineering. That's completely fine.
We've got this question later on, and what in general, what advice would you have for someone who's trying to choose between engineering and physics and engineering and maths? Does it purely, as you said, come down to the course, or are there?
So the balance is going to be different in those subjects. So you do maths, there'll be a lot more pure maths, a lot of kind of logic and proofs and numbers, as well as applied maths. So there's a different emphasis. Taking maths as an example, you can get onto fluid mechanics doing maths, which is close to what I do in engineering. So there's that overlap. I actually teach some of the maths in engineering. I'm not sure what the maths fellows would think of what I teach, but anyway, there's an overlap of the maths end. But if you're and physics, that's going to cover a lot of fundamental science as well. So if your sort of motivation is applying those things and making it in the broad sense, and could be making something physical, but it could be computing, software, AI, algorithms, but developing new things and coming up with the ideas and developing technology, then give engineering proper consideration. That could be for you.
Nice. And in terms of life after university and different careers, say if someone's a bit unsure of which to choose between maths, physics, and engineering, can you go into engineering roles if you were to choose maths or physics?
I'm sure that there are ways in. One thing about our engineering degree is it's accredited by the different engineering institutions. So that puts you on a path so you can become a chartered engineer. And some companies would value that, and they would value the experience that you'd got in engineering. And then some companies would say, well, I need somebody who's going to make help us develop, electron microscopes. So natural science background's perfect. So it's going to be dependent. One thing to say is that the number of things that our graduates go into from engineering is very, very diverse. So there's all the technology we were sort of discussing at the start. You can imagine working for the companies that make those things. They could be small companies they go to, or multinationals, like coming up with devices, I don't know, transport, cars, airplanes, or it could software, or the application of new techniques to physical systems. I'm thinking of AI. How do we connect AI with involve it in real embodied products? Engineering consultancies, so full sort of range, but also because of this sort of problem solving mindset that you'd have after having done the engineering course, that's also tends to be valued in its own right. So you could go into something that was less obviously engineering, but people knew you were going to sort of tackle things in a logical way, in an organized way, and get take on that aspect of the job. So there's a big range.
Huge, lots of opportunities if you to do engineering. And just the one last question about careers and companies. How often is it like in whether it's in research or in an engineering company, that is there much collaboration between people who've come from, whether it's a maths background, a physics background, a natural sciences background with engineers, or are these in research just all engineers? You see what I mean?
It depends. So one thing to say is that in engineering, we often work very closely with industry. So on a research side, in order to have impact in problems in society, we often collaborate with industry. So we'd be working at one end of the technology development, and then we'd say, right, we think this is ready to go as a concept, and as back and forth. So it's good to sort of recognise the role of industry, and then in industry, for sure there'll be. I've worked with in companies that look like straight up engineering companies, and they might be hiring mathematicians to work on different aspects of their simulation modeling, and they might be hiring computer science. We haven't mentioned computer science. That's another option. There's again another back. So we touch on more than touch. There's a lot of computer science in engineering. So if that might be a decision for some students. So again, just try and go quite deeply and try and think which aspects excite you.
Because I guess computer science can lead on to software engineering at a later stage.
Yeah, for sure. Yeah, definitely. So, and lots of engineering graduates go on to work on software. So yeah, it's not, and so just try and make the decision based on what it is you want to put a lot of time into for the next 4 years in the case of engineering. And that should steer you in the right direction.
Nice. So with regards to the teaching, you mentioned before that there's labs and lectures, but I also imagine there's supervisions. Can you explain to us what they are?
Really important kind of resource. I think it's amazing that so what happens is the students get we call them examples papers, so a list of problems, and that's associated with each lecture course. So you're going to get these problems to do, and that's homework. So you're doing those, and the real strength is that instead of just doing those for your own benefit on your own, or not or going to a large group class where you might go through them, you're going to take them along as normally 2 students and one academic in the supervision, and you just able to ask questions. Well, I did this. sort of got to the answer, but I'm not really sure why that worked, or I couldn't do this. What should we do? And you're all working on it together, and then the supervisor might have a completely different approach from the one that you were trying to follow. Might be able to say how this kind of knowledge is applied, outside the course. Might be able to reach for an exam question that involves this topic, but is sort of asked in a slightly different way. And whatever stage you're at, because it's just such a small group, the supervisor can respond and get you through it. I think it's a real plus of the system.
Nice. And it's something that's specific. I think the tutorials happens in Oxford as well, and as well as Cambridge, but in most universities, classes have bigger groups than 2 people. What do you think, if we didn't have supervisions for the engineering course at Cambridge, what do you think would be lost without the supervisions?
So it's that tailored guidance, really. Tailored help. So often students are getting stuck in the same way, or there's certain sticky points. So a lot of those you could handle in a class of 30 or something coming along to see how you do these problems. So that works. But the extra point here is you can go a bit deeper in some cases. You can bring in different topics that are relevant, and whatever you can do that's kind of tailored to not only the problems and the subject, but also the student, or the small group of 2, maybe 3 students in the room. Yeah, that my view. Hopefully, students agree that really helps. And one thing is that the terms at Cambridge are quite short. They're short. So and there's a lot going on.
Yeah.
So I think these supervisions are going to keep you on track.
Yeah.
But also they're going to help you do the stuff. So I think the 2 things go together. The short terms and the sort of rather busy, focused, sort of condensed experience works because of the supervisions. So I think they're a key part.
Yeah, nice. And do you know how many supervisions would students get? Is this like a few every term, or are they every week?
Every week. So normally a couple a week.
Okay.
Yeah.
And each supervision you would have handed in a problem sheet beforehand.
Either that, or you bring it along to the supervision.
Okay. So
and you sort of go through it there.
Yeah, 2 a week on top of the lectures and the labs. It's busy.
The one thing we didn't talk about is most of the lectures and labs are in the mornings.
Okay.
Some on the timetable are in the afternoon, particularly like a drawing session. Some other lab sessions, the odd lecture. But the focus is your lectures and lab experiments are in the morning. So you've got this time. You've got the rest of the day, to do whatever you want, and some of whatever you want should be these examples papers. Yeah.
Nice. And just very lastly, you mentioned there I was wondering what's a drawing session for anyone who doesn't know what that is.
So in the old days, it was. It's not like.
Yeah.
It's not like see if I can sketch stuff.
Yeah.
See what it's not like what's it called, a bowl of fruit.
Yeah.
So it's a
life drawing.
That's right. It's a technical drawing. So
okay.
Some of the objective is to convey the normal objective is to convey to someone what they should be making.
Okay.
So for that you might do you would draw this object in computer-aided design software. Normally now you would draw that you would construct it as a solid. So that means that the software knows it's 3D.
Yeah.
And you can either, so it's about that. How do you do that?
Yeah.
You can sort of communicate that as a 3D object, send it as a file. But also the old way was to construct views of that. So the views would be constructed in a certain way. So some people would still be looking for that on their drawings. And how do you put dimensions on the drawings? So the thing comes back the right size. Is this a kind of arbitrary shape, or is it a sort of fixed radius here? So there's like labeling conventions, and how do we show tolerances? Like it could be this size or slightly bigger. There's quite a lot to it.
Nice.
I should probably say that drawing a bowl of fruit is also useful, but maybe not for the engineering drawing.
No, that sounds. I think it sounds like a really cool opportunity for those who are maybe quite practically minded and want to create things, but also love their maths. It seems like a perfect course for that. Well, thank you, Graham, for such an interesting podcast. There's so many engineering applicants every year, and so many people have questions about it. So I think this would be really useful for those who are thinking about engineering. And thanks for the viewers for watching. We're hoping to do podcasts on the remaining subjects that we haven't done. And so have a look out for that, and we'll see you guys next time. Nice. How do you find that?
Yeah, randomly talking about still lifes at the end.